Hello and welcome to MATHurdays. Math's so fun we do it on Saturdays. I'm Teresa Wells. I am, my background. I've been teaching online now for 11 years. I really enjoy teaching online, but regardless of your modality, I'm here to showcase a math routine and a rich task that is geared for middle school, but I promise even if you don't teach middle school, this will be accessible to you and your students. That's kind of the focus of what I do. And we're gonna jump right in. I think most of you have the link to the interactive slides. That's how you got the Zoom, but just in case, it's right there. And on slide 2 is where you can go to get contact information, get in touch with me, and more. On slide 3, I've got where you can go for templates and for previous recordings of MATHurdays. So if you're looking for more routines, more rich tasks, more videos of how this looks in the classroom, there are over 50 available on the MATHurdays site. And we always start off by just kind of working on our community, finding out where people are, what they've been up to, what they're doing. So if you join me on either slide 4 or 5, insert a text box, but feel free to use animations, pictures, and more to tell us kind of what's going on. And Lily, how is that spicy chili crisp?
Hi, Teresa. My father is Chinese and my mom is Japanese. I grew up in Japan. So, as you know, Japanese food is kind of on the bland side, nothing too spicy. So I never took any liking of the chili sauce, but my daughter has been just absolutely crazy about it. So we decided to spend the summer experimenting several noodle dishes and vegetable dishes, and it's been marvelous, absolutely marvelous.
How lovely. I do enjoy a lot of different flavors as well. Lisa, how is I see you're in your car, but if you have your mic available, how's the proportionality workshop?
Oh, it's great, Teresa. I hope you can hear me. I'm having a great time with it. Learning a whole lot.
Awesome. And I'm excited because cicadas are gone, so I'm going out more and doing more walks and stuff. If you are in the Northern Virginia or Maryland region, you know exactly what I was talking about. There was just billions of these little bugs like everywhere, and they're finally gone. So, let's see. Oh, Gail, how's it looks like you're out in Chicago and surviving a tornado. Oh my goodness, how's it going?
Yeah, it went through Sunday night. It went over us. It took down trees. Our house is fine. One of the trees fell on the neighbor's house. That's a 40-ton crane lifting a piece off. A lot of damage, but people are okay.
Glad to hear people are okay. I mean, that must gotta be scary, and glad you're okay as well.
Very scary, very loud. Go to the basement.
Yeah. Whew. Goodness. Raha, how is it being able to see your nephews?
Hi, Teresa. I lived with my nephews for like 8 years, and then I started working and I moved out. So this was the longest I haven't seen them. My sister was very careful about the quarantine and just stayed quarantined until everyone in the house was vaccinated. So it was a very nice birthday present to myself that I got to see my nephews, and they're so tall. They're just so tall now.
Yes, that's how I feel when I've finally been able to see people I haven't seen in a year and a half. It's just like children and their kids, and everyone's growing, and yeah. All right, folks. Well, welcome again to MATHurdays. We just always kind of start off with a little community building and see where people are in their lives. One of the nice things about the successes and celebration slides is that you can see even more than we would be able to share over the airspace. And we can even kind of comment back and forth, send links and more. And so it's such a great way of being able to connect with other people. So we're going to jump right in. I'm going to start us off with a math routine. The link for more resources is on slide 6. This routine is not my own, but I tried to adapt it to the online space and give you some ideas for things that you can use in your classroom. And so this is Get Riddles. And to access this, we're going to start off with our chat box. So you might need to minimize your browser window, find your chat box in Zoom. And we're going to have 2 minutes of think time for this riddle. And the way we're going to respond is a chat waterfall. So just spend your think time not rushing, thinking about a numerical answer, putting it in the chat box, but don't hit enter, because we're all going to hit enter at the exact same time. That way we can see a whole range of numbers that people's ideas were. It says a duck was given $9, a spider was given 36, and a bee was given 27. Based off this information, how much money would be given to a cat? Multiple answers are awesome. Think about your reasoning of what you would give the cat and why. You'll put a numerical answer in the chat, but don't hit enter yet. And welcome if you're just joining us. We're having some think time on our riddle on slide 7. Putting our response in the chat box, but not hitting enter yet. All right, go ahead and hit enter. And like any good waterfall, you can continue to put more ideas in there as the thinking continues. Kathy, let's start with you. You said $99. Tell us why you think $99 for the cat.
Morning. I just went with the multiples of 9. I saw all the values related to multiples of $9, and I felt that people like cats better. But my original thought was how many dollars per leg, and I kind of ran into a dead end on that one because duck has 2 legs, spider has more, and anyway, so I gave up on that and just went, that's what I thought.
Love it. People like cats better than ducks, spiders, and bees. I would generally think that that is probably, on average, correct. It looks like, Lisa, you thought of a way of using legs. You said 18 because 9 for every 2 legs. Can you unpack that a little bit more for us?
Yeah, so it took me a little bit. Sorry, which Lisa?
Oh, goodness. Hi. Lisa, is it Aldos?
Aldous, yeah.
Yeah, how did you get this 18?
So I was trying to find the relationships between the 9, 36, and 27, and so I used basically 9 as 1 unit. So a duck would have 1 unit, a spider would have 4 units, a bee would have 3 units. I was like, well, what is the relationship there? I was like, oh, 1 unit is 2 legs. That would mean that the cat would have 2 units, or 2 times 9, which is 18.
And Lisa, am I writing these numbers down right? It's a duck was 1, spider was 3, bee is 2.
4. Spider is 4, bee is 3. And each 1 unit would be 2 legs. So therefore the duck has 2 legs, spider has 8, bee 6, and cat 4. So then I just multiplied all those numbers times 9 to get our equivalent dollar amount.
Oh, that's neat. So you kind of counted for every 2 leg.
Yep.
Let's go to Lisa Hudson also. You came up with legs, but it looks like maybe you did it a little differently. How did you do it different from Lisa Aldos?
sort of thought about how Lisa said $9 for every 2 legs. The first thing I noticed was the duck. And well, I saw the multiples of 9, and I was starting to think, okay, duck has 2 legs, and I just thought of the legs, and I said, okay, does a spider have 8? I think so. A bee has 6, so that left a cat to have 4. So I like how she has $9 for every 2 legs, and that's really what I was thinking of.
And so did you stick with the skip counting multiples of 2, or did you take that 9 for 2 and change it into per leg?
I left it 9 for 2.
Left it as 9 for 2. Cool. And one other one. Raha, you said 12. Can you tell us what you were thinking?
So clearly I did not make connection to the legs. As you can tell, I'm not very animal friendly. But I was thinking about all those numbers are multiples of 3. So if it's a multiple of 9, it has to be a multiple of 3. And I just figured since a duck is pretty much not similar, not same size, but maybe similar size, and the bigger animals had a less value. So I went with 12, not thinking about 18. But now that I see the connection of 9, maybe I would have estimated 18.
So that idea, the bigger it is, the smaller that value there. Very cool connections. So folks, the reason that we picked, that I started off with Get Riddles is because I thought that this little riddle, no matter how you did it, gave a great opportunity to think about some proportional reasoning, which is what we're here for. You'll also notice there are some interactive tools. I meant to do this earlier, but we can still use them now. A smiley face is like, yeah, I saw it that way too. I agree with you. A heart is like, whoa, didn't think about that, but love that one also. If you want to move that little smiley face and heart over to the side, you can let us know if you agree, if you didn't think of it before, but you love it. And you can kind of give some interactions that way. And typically I would have done that in the middle of it, but I was just too excited about the different ways that you all thought of it. Cool. Well, on slide 8 is the protocol that I use today if you're looking to do something similar. It's not that this is the only way to do it, but this is how the chat waterfall, I got a response from everyone. The share it, I looked specifically for 4 different ways, and having the little emojis not only keeps us busy, but lets us also kind of make some connections with other people. All right, let's jump into the rich task, what many of us are here for. On slide 9, I have the rationale for why on earth do we do rich tasks? Yeah, they're fun. Some teachers like me love them, but really why? And today you'll see a lot of mathematical representations, a lot of discussions, a lot of conceptual understanding, and the response, the discussion that we get is going to be all based on your thinking. Whatever you supply us is going to be what we use in our discussion. And before we start, I have a problem-solving oath on slide 10. I give this oath opportunity to everyone, whether you are 5 or a veteran teacher who's been teaching for 50 years, and everyone in between. As I read it out loud, read it to yourself, and if this is a pledge you want to take today, put your name in the chat box. I, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. And I can see we have lots and lots and lots of more problem solvers with us today. So here's our task. It comes from an infographic on slide 11. And I put the link in the presenter's notes at the bottom because I know that the font's a little small. You might want to zoom it in. So down in the presenter's notes, that's underneath the image, is the link for this, and also for citation purposes. But this is a really cool page of a book, And under Big Thinkers, it says the size of an animal's brain compared to its body can give a basic idea as to the intelligence. This means that a cat, a ratio of 1 to 110, is much cleverer than a hippopotamus, ratio of 1 to 2,789. And the simple question for today's task is a sperm whale smart? That's it. On slide 12, there are lots of little images. If you want to copy and paste to compare them, you'll notice that the sides are not proportionate at all, very purposeful. However, the brain size appears to be from the infographic. When you're working in your groups, consider how you're going to decide if a sperm whale is smart. You might have to do some other internet searches on how big these other animals are, but they do give you the brain size on slide 11. Everyone will be in breakout rooms. Your room space is below on the slides, but if you need more, just make more. And I'll be popping in as well to hear the discussions that you're doing. And I hope you enjoy this very open task. All right, our breakout rooms are starting now. If you turn on your microphone, say hello to your new buddies. You should have just gotten your invite in Zoom.
Think about the animals that are considered intelligent, like dolphins and monkeys, and look at their ratio. Well, and humans, and look at their ratio.
Sometimes.
Yeah, and then look at the ratio of how the sperm whale compares to that.
So something I'm thinking about is that the weight of the animal. So I guess I'm trying to figure the numbers out that are given on the infographic. So we have grams and pounds. Would the pounds be... See, that's what I'm trying to figure out. There's no way. Is the pounds for the brain?
I think they're both the same. Isn't 680 grams like for the giraffe 1.5 pounds?
Oh, I see. So it's already... Okay.
I think that's what it is. Let me
No,
just
I
verify.
think you're right. So maybe we might have to...
She did say that we might have to look on other sites, so we might have to look up what each animal weighs.
Yeah, like an average weight.
Yeah.
Okay, so average weight.
The cat is, we have the information about the cat though. It is 1:110, and we know the cat is 30 grams, the brain. So it weighs 110 into 30 grams.
Well, according to the internet, it should weigh anywhere between 3.5 to 4.5 kgs. So about
Exactly. Here it's 3.3
3,600 grams.
kgs. Correct.
Yeah.
So I guess first, do we want to stick with grams or do we want to stick with
What I was thinking too.
Yeah, but you know, aren't humans supposed to be the most intelligent? I guess. I mean,
I hope
think,
so.
And
Who is Lisa? What did you say?
aren't humans supposed to be the most intelligent?
Mm. And our brains aren't that big compared to some of these other animals.
Mm-hmm.
Let's see.
Okay, so maybe we make an assumption.
Let's think about what we've heard about other animals, like dogs are smarter than, let's see, what, sheep are supposed to be really dumb, right?
Oh, and dolphins are supposed to be smart, aren't they?
Yeah.
But then I also hear the crows are really super smart.
Oh, wow.
They remember human faces, and the faces that they don't like, they attack together as a group.
Yes, and they're very social.
So-
They stay together.
Mm-hmm.
Okay.
But I know that the cicadas are not supposed to be.
Sin.
What if we just took, yeah, I like the table idea, but we could also, oops, that's really big, sorry,
Okay.
add in a male and females?
Yeah.
Some each.
I mean, hold on, the infographic didn't say male or female, did it? Oh wait, yes it did. Oh, you put that. Okay.
Yeah. Sorry, I think it might be big again. I'll just make it small.
Into body. So because the ratio is smaller, that means that the cat is more intelligent.
Yes.
So 30 grams, and the cat is 1 to 110.
Hi there, group. I noticed that Brian has a little companion with you
I
there.
know. Every time I'm talking on the computer, she feels like they're talking to her.
In this case, we are, Kitty.
There's that 1 to 110 ratio.
That's it. That's it.
What's your cat's name, Brian?
Claire.
Aww. See, Claire knew that we were discussing her intelligence.
There you go. She's pretty smart. Yes.
There's that 1 to 110.
That's right.
What was the ratio for this? Does it tell us for the sperm whale or not for the?
No, it just gives us the mass in grams, in pounds. So it just says grams to 7,800.
And then the sperm whale ratio, oh, sorry, you said it and then I didn't write it down.
Well, it was just 7,800 grams.
Oh, right, it's the hippo one. It's the one that
Oh,
they
the
gave it to
hippopotamus
hippo.
was 1 to 2,789.
Okay. Right, so let's see if we can notice, let's see if we can try to find a pattern, like since we have the information for the cat and the
It's to 17,950.
That sounds incorrect. We're definitely smarter. Okay, what did you say? 17,000?
948.
40.
I mean, it's 48 is based on that. Whatever, 41,000 and 14,000.
Well, you know what I'm thinking? Because it doesn't specify what gender for this on the infograph, I almost wonder if this is probably either a male or a female, because the weight and brain mass have to be at some rate proportional, right? So
You would think.
it wouldn't be the same size of the brain. And what was the weight for the females, Leo?
14,000.
Hi there, group.
Hi.
It sounds like you have moved into male and female whales. Did you notice a difference?
We did, and we were wondering, like, that the infograph isn't giving us a specific gender, so we can't really assume this has to be a ratio based on the weight. So if it's a female, the size of the brain for the female has to be different. That's where we are right now.
Our clever ratio is off, isn't it, as well? Shouldn't it be 179, 1 to 179?
Gotcha.
0.48 if you want to.
Interesting.
So according to this, the female is much wiser, but like you said, their brain might have a smaller mass if the whale is actually smaller.
But we are given the brain size for this whale, aren't we? For this particular one on the infographic. It says it is 7,800 grams.
Right, but we're saying we don't know if that's a male or a female.
Right.
So do we average a male and female weight and then?
So I think either we assume it's male or we assume it's female or we assume, both cases we look at.
I think I like what I see so far because average just, there's such a huge difference that the average might not suit either.
Right, it might be too skewed.
Yeah.
All right, let's talk a little bit more about that. Why wouldn't we want to average this?
Well, I think if we try to average it, then we need to average the size of the brain as well. Because if we're thinking about scale factors and we're thinking about, okay, if we're finding a proportion between the weight of an animal and the size of the brain, we would, I don't know if I'm making sense.
It might make sense to average if we knew that the mass of the brain was an average.
Yeah.
If it is for a specific animal, then whether it's male or female, it is a specific one. It's not an average. Or of course, it's an average of all males, but yeah, it's not average across gender.
So often when I think about averages, I think about this, it was supposed to be a joke, but it really hit home for me. 3 teachers and Bill Gates walk into an elevator together, and someone goes, "Hey, look, on average, we're all millionaires."
Right.
So here we've got a whale that is, their clever ratio is extreme in one way and kind of extreme in the other. And so when we find an average, it's important that we know like why we did it and what it means. So I'm going to have you all keep thinking. You're on a great track.
The test that you shared with us a couple of months, I don't even know, weeks ago. I don't know how long ago it was. When we found the mean median of that population and whether you would live in this country versus that country. And that's when we talked about average is very skewed because average could mean so many different things based on the poorest person in that country versus the richest person in the country.
Right, yeah.
But
I like the odds that the female sperm whale has right now. So
oh yeah, we agree to that.
I sort of thought they were, but I could be totally wrong. We always talk about elephants being so smart.
Mm-hmm.
I mean, I'm even eyeballing this, looking at the size of the brain to the whole body just in the picture. And if you look at especially look at the baby's brain compared to its body, then the adult brain, it's hard to tell with that picture. Then look at the giraffe. Whoa.
Alligator, I thought that wasn't an eye, but I guess that's a brain right next to the eye. The little speck of green.
I just observed that too.
Somehow I wasn't paying attention to it. Okay, so when we say the average size of monkeys, what should we go with? I guess
I'm thinking group 3 went with a cat.
Just thinking, I love that.
That's one of those things, and they have 30 grams, 0.07 pounds. which is a ratio of 1 to 110. Let me see if I can find how they got that. 30 divided by 0.07.
Okay, and I'm doing the human calculations, very interesting, on a quick Google search. The average weight around the world for a human is 136 pounds, but in North America it's 178. So I'm doing both of those.
Okay.
Interesting.
Okay, so they are doing something to they've got to be converting something to the same units to get that ratio.
Uh, 45 and a half-ish.
So I think it might be interesting to do the alligator because the average weight is 790 pounds.
Okay.
And its brain is only 0.18 pounds.
Wow. It's almost hard to believe that that small of a brain can actually control all the functions, but I guess it's alligators don't really think, they just are.
Yeah.
That's crazy.
Well, clearly the female sperm whale is smarter.
Way smarter than the male. She didn't say how long we have in here, did she?
Teresa, how long do we have in here?
Hi, yeah, I just happened to be in your group.
Oh, she is in here.
I usually go until about 12:40. So whatever hour yours is at 40, we'll come back together.
Okay. All right, do we want to do one more animal?
You gonna run the ratio on that?
Versus the brain size. Like, I think...
When it said, let me see what it brain size. We said brain size was 7,800 grams or 17.2 pounds.
Yes. So I wonder if like we can start there by looking like at the relationship between 7,800 versus the 130,000, right?
Okay.
Like that's what I'm noticing. Hold on. How much was the sperm whale in pounds? Because if I do it all in pounds, that would be better.
Okay, 17.2 pounds was the size of the brain.
Okay, 17.2 pounds.
Mm-hmm.
Since the weight was in pounds, we could do pounds to pounds. Whoops.
There we go.
Not what I meant to delete. There we go. Okay, so 17 to 130,000, 700 to like I think it will just stick with the cat being 11 pounds. Sorry,
Wow.
cat.
And the hippopotamus's brain was 1.3 pounds. I don't know if I gave you
To a body weight of 8,800.
to body weight of 8,800. Mm-hmm.
So what is it that makes the cat clap?
So that means a newborn is more intelligent than an adult. I guess that makes sense because the brain mass is higher in proportion to the uh,
So the
body.
clever ratio doesn't really have to determine the standard of the choices we make. So newborn makes very few choices and still they're much cleverer.
Well, I think we always talk about how like a newborn's brain is very observant, like it's able to learn more information faster versus our brain when we're learning, for example, a language. So they just don't have certain skills to share that information. Does that make sense? I don't.
And most of it is geared towards survival.
Right.
It's more like a reptilian brain.
Right.
But that does make sense that proportionately
They're more brain than us.
Yeah.
And yet we discount them.
Well, because as adults, we feel like we know better, but it's not always true.
Nope.
All right, if you're watching this recording, there's a couple things that are important to note here. I did need to go into my own space, the main room, in order to sort my ideas out because there's clearly a lot to discuss here. But I think what I want to start off with the basics of middle school, understanding proportions and reasoning. How did you make sense of the grams per pound? Group 4 really brought that up with which one do we want to stick with. Laura and Brian made sense of this early when they were trying to just convert to just use pounds as the same. But in middle school, a big concern is not necessarily that I know how to cross multiply and divide, but more of it, does my proportion make sense? Am I going the right direction? And am I multiplying or dividing, getting larger, smaller, and the reasonableness of it? So I'd like to get that out. And then I'd like to talk about how people are comparing two things at the same time, which is often what a proportion is. Here on group 4, they are looking at a male and a female. Group 2 is also looking at a male and a female. sperm whale and the difference. And group 4 also looked at an adult and a newborn child. So these are like two different things at the same time that they're comparing. The other neat comparison was on slide 13 when they are bringing a table versus slide 16 when there is a visual. So those are the many things I think I'm going to try and bring up. Hello everyone, and welcome back to the main room. I hope you had some fun with that problem. The infographic was enough to make me feel like I could have done a whole unit on it. But during this discussion time, what I want to be able to be purposeful and model are the 5 practices for orchestrating productive mathematics discussions. Slide 18 has the 5 practices kind of spelled out. I've already anticipated the pages of ways that people will solve this problem. I monitored, you saw me popping into the rooms where I'm gathering ideas, quotes, asking questions, and more. And I've selected and sequenced these questions. Today, we're going to talk about the important concepts that middle schoolers are really focusing on. And if you teach elementary, what is so important to build the skills on so that they're successful in middle school. Then we'll go into some different comparisons. And then we'll talk about real structure. Like this problem was really open. It may be too open for your middle schoolers without the right responsibilities and structures involved. So how do we kind of bound it a little bit more to give more structure? So here we go. I'd love to start on slide 19. If someone from group 4 can tell us in your initial conversations, you were looking at the 2 numbers on slide 19 for this giraffe, and you were trying to figure out what they were, how they were related to each other. At the very beginning of your discussion, why was this so important?
Well, this is Heather from Group 4. I think we had to build, first of all, to see what that meant. With that slash there, that's a math symbol. So you have to first start thinking, what does that mean in this case? But you also have to look at, do we want to work with grams or pounds? And it was a comfort level. The other I'm not particularly comfortable with grams and kilograms, but they are easier to convert. And when I Googled, I came up with all pounds, but other people were Googling in other countries and they were coming up with kilograms. So I specifically had to Google the weight of an animal in kilograms to get it to come up in Massachusetts as kilograms. Usually it diverts to pounds. So that decision was the first step because we had to decide how we were going to work together, I think. And anybody feel free to correct me. I tend to ramble.
I love your explanation.
I think you said it well. Yeah. Yes, Heather.
It was also the relationship, basically what Heather said, the relationship between grams and kilograms, because 1 kilogram is 1,000 grams, so it was easier to do any type of ratio when we were dividing, versus with pounds, it's a little bit more trickier with that conversion. So we just stuck with grams. It was just easier in the metric system.
So different groups use different units, which is one of the things that makes this problem so interesting. Is in our case, we actually had folks from other countries, and the units that you use may be more preferred in the country you live in. But even, when we have students in groups, they might choose metric, because I don't know about you all, I like metric. It's base 10. It's super easy for me to move between. But because most of my life I've used standard units, I am not as familiar. Like, I don't know when it comes to grams how much I can hold in my hand, but I know a pound what I can hold in my hand. So that's something that I'm still working with and conceptualizing here. And Laura and Brian, in your group, you started off with some different units, and then you were like, let's just go with this one. What decision did you make, and why did you make it?
So I think when Brian and I started charting, we started just recording everything. And I was recording, and Brian was started doing a great job, like searching the internet. But the information that Brian was finding was mostly in pounds. So even though I initially was preferred grams for the same reason that Raha said, it's much easier to work with grams because the ratio is 1 to 1,000. All the information Brian found was in pounds, so we had to switch to pounds because that's the information that we were finding on Google.
Very cool. So you had to kind of convert between those also. Google has some great conversion tools where you'll type in ounces and they'll go into pounds or any way, this way and that. But one thing that I find really interesting with young children when they're learning to convert is that they don't necessarily know which way it goes. So that idea of conceptualizing which is bigger, and am I going to be multiplying this by 10 or dividing this by 10, and really bringing out that reasoning. The next thing I wanted to take a look at was the comparison between slide 13 and 16. And so I'll let you all kind of navigate that between 13 and 16. If we could have anyone really, but if you are in group 1 or 4 and you see connections between these, how are these different representations good for understanding relative size?
Sorry, Teresa, could you repeat the question? Sorry, I didn't quite get.
How could we use slide 13 and 16 to kind of compare for similarities and differences?
I think both groups were trying to find like a range. At least in group 4, we tried to start with like the cat, and then we immediately went to whales, but then we thought about, okay, what about the other animals that are given to find that comparison? That was what we were kind of starting on conversation towards the end, is like, how would we explain which one is smarter and which one is not? And then we, some of the group members talked about relative comparisons to talk about which, like, find that range, like where would the sperm whale fit in between?
So where does it fit in between, knowing that it's going to fit somewhere? So the one neat thing I like about 13 and 16 is how we have both a visual and we have our table, just trying to bring those two mathematical connections to kiddos. But now let's get into like the nitty gritty. So in middle school, we're all about proportions, comparing oftentimes two things or two things at a time in order to figure out more. How about let's take a peek at slide 14. And this group really talked about the two different sperm whales. So what were you all comparing here on slide 14?
I guess I'll share for our group. So we at first we were like, we looked up the information on sperm whales and we're like, there's a humongous difference between the males and the females. But we couldn't find any information on difference in brain size. Like there was one website that said that their brains are a little different, but we couldn't find any specific data. So we just used the 17.2 for both. And that kind of showed us that if in fact their brains are the same size, then the female sperm whales are way smarter than the males. So we kind of discussed why that is, the differences. We actually kind of dove a lot into like how sperm whales live, and we're talking about the females raising their young and living in the pods while the males are kind of separate. And we were trying to figure out what really was that difference, if that is in fact the true ratio, if the brains are the same size. So we talked about that a lot, and then we compared it to a bunch of different animals and just thinking about the different behaviors and how animals act, how they get their food, and how that was related to this ratio. Anyone else can add in from group 2.
I love your conversation about range. So if that was the brain weight for all, then our range would be really drastically different. But another group was considering the same thing, like let's compare male and female. They found another comparison there. And down on slide 21, this was their work where they were. So if you join me down there, this group was talking about a similar thing, and then they came up with the concept of should we take the average? Group 4, can you tell us a little bit about your conversation and how that was similar or different than the previous one?
Yeah, I could go on this one. Yeah, so when we looked up, it turned out that sperm whales, the body mass was very clearly given as for the male and for the female. And the difference was significant. The female was about 14,000 and the male was about 41,000, which meant this ratio was on either side of the, of the rhino, of the hippo or the rhino, the other beast there along with the cat. So then I think we were wondering how to nail this down, because the figure shown would be 1. We were wondering whether it would be wise to take the average. But one value is 3 times the other. So the average is may not reflect much. And then Teresa came in and gave us a little story of Bill Gates and the 3 teachers in an elevator, and how then the average salary of all the teachers is also not the average salary, they're all millionaires on average. So it was very skewed. So we did not take the average, and so we left it as 2 separate ones, although I think everybody was not too comfortable with that perhaps.
It was a great explanation. The idea that, like, should we take an average or should we keep that range in our discussions? And then one of our groups also looked at an adult versus a newborn. What was your thinking there when you compared the adult to the newborn? And that's on slide 22.
Oh, that was in group 4 as well. And it was just trying to figure out whether, when we're trying to figure out the clever ratio, just to see something that we can compare it to something we can understand. And then it actually just confused me a little bit more, because according to our clever ratios, the newborn is a lot cleverer. So we had a little discussion about that as well.
So what did your discussion come out with? Do you think that a newborn is more clever or less clever, and why?
We did talk about the capacity to learn at the newborn. That when you're an infant, you're learning it's your capacity to learn and your capacity to take in information is much greater than as an adult. So we did look at that. I don't know.
Yeah, so, we could start to extrapolate information, but what we're really doing here is we're asking ourselves new questions. How do we determine smart? How do we determine clever? Is it the ability to survive? I heard a lot of survival instinct coming into them. Is it the ability to do more than just survive? Is it the ability to keep your offspring alive and more? And so then it gets into those bigger questions, which is great for, cross-curricular and researching in there. But for the mathematics, here's what I'm thinking about on slide 23. There were three kind of important questions that grounded this for me as an instructor. One of the things was what's important when considering converting between units. Are ratios easier to work with than setting up a proportion where we have two equivalent ratios here? And how do we use proportions to solve some unfriendly numbers or unfriendly comparisons? So this was a very open task. There was a lot of ways to solve it, which is why I love to start a unit with something like this, where we don't have definitive answers. We just have a lot of interesting concepts so that throughout the unit, we can keep bringing this up. Remember when we changed to conversions here? Remember when we were looking at the range between male and female and more? But let's put our collective brains together on slide 24. If we were to give more structure to this and ask a very specific question that students could solve middle school grade level, what would it be? How might you take this really open task and bound it into a single word problem, a single concept? What might we ask them? So now we're starting to see a lot of the other standards come out, comparing any two at a time, ordering them. This idea of just because it's the biggest, does it mean that it's the biggest in comparison to the size? So are we thinking additive or are we thinking multiplicative reasoning? Converting, average sizes, comparing any two, comparing rodents versus larger animals. Is there maybe categories for brain size? And then there's the proportion of female and male with the average sizes as well. So this can bring up so many of these initial questions. And I have students develop this list of questions also, like try to outsmart the teacher. What questions could you ask from this data? And then whenever possible, those questions come up again in the unit, and that informs our unit. And we can continue to think about mathematics in this way that we don't always know all the answers. But when we tell someone, hey, I think this is smarter, we should always state our reasoning why. I think this is smarter because it's a bigger brain size. And that way someone can oppose to say, well, brain size doesn't necessarily mean the smart level. And if we come all the way back to that image that was supplied to us, I know some groups saw this. In the upper corner, it even says bright sparks. Size isn't everything, though. When it comes to intelligence, humans have more, what does it say? Cerebral neurons, the nerve cells that make up the cortex of the brain, which puts them on top of the intelligence ranking. So now we have another thing that we can include with that. Well, folks, there we go. That's the top of our hour. I hope that you've had fun with the routine that looked at different ways to think about proportions, the task, and the many more tasks that come from it. I have more MATHurdays coming up, and the dates for those are on slide 26. And if you have any questions, comments, or more, pop them in the chat box or just turn on your microphone and talk. I had a lot of fun today. Hope you did too. And I'll have these all back up on my website if you want to use any of this in your future classes.
Thank you.
Hi, Teresa.
Hi.
This is my first time attending one of these sessions, but I learned quite a bit from it and can see how I could definitely use it for my math students in 7th grade this coming school year. So I'm definitely going to be pursuing this. But one of the things I wanted to find out is I'm still trying to figure out how to do this entering information into the slides. So I didn't know how to go about doing that. And if I do something similar with my students, I want to be able to tell them how to go about doing that as well.
Yeah, so are you able to edit the slides right now the way that you're on?
Well, right now I'm doing full screen. So if I go out or exit out of full screen, I actually have your copy of the slideshow, and then I made a copy.
Gotcha. So one thing that's really important when we're working in collaborative slides, I'll put the link in the chat, is that we're all in the same link at the same time. That lets all of us be able to edit. Now, interesting thing, when I first started teaching online, we didn't really have a good share screen feature. And just like putting yourself on mute is considered like considerate, having your camera off was considerate back then because it would just lag everyone's internet and slow us way down. So we just had like the chat box open and we could hear each other. And so most of our, what we would call like our real estate on the screen was those interactive slides. And that's where we did everything. We just kind of heard voices. And that a lot of that comes out of the video game community. They don't necessarily see each other's faces, but they hear each other as they're, defeating monsters or whatever they're doing on their games there. So when it comes to working with the children in it, I kind of start us off with, you're going to be in breakout rooms. Here's your collaborative slides. And at the beginning of the year, I'll, kind of do some activities to make sure they know how to do text boxes, copy and paste images, move things around. And a big one is how to hit the undo button or Control Z so that they can undo their mistakes.
Right.
And I'll often start them off. Each group has their own slide deck just to make sure that we're feeling responsible and we don't delete other people's stuff. Once that responsibility is there, once people are, they know how to do that, they know how to undo stuff, then I usually throw all the groups together like we did today.
Okay. Well, evidently I missed that part at the beginning when you were doing this as a collaborative set. I saw the link, but I already had the link. I already had your slides on my screen, and I said, "Well, that's what I need." But evidently, that's not what I needed. I need the collaborative slides. So that makes a big difference.
Well, Brian, I know that you had a great group mate with you that was supporting, writing it in on the slide and stuff. But
Yes,
I do
ma'am.
hope you come again and interact with it. For a lot of people, it's the practice of working together and trying out new things and hitting undo that is really effective. But yeah, even the sessions that I do with elementary teachers, they are ones that gear up into Algebra 1 and beyond too. So yeah, feel free to show up for any of them, and we just kind of work together as a community to learn the Google Slides and unpack the mathematics.
All right. Sounds wonderful. Thank you, Teresa.
Thank you.
Thank you, Trish. That's lovely.
Teresa, I was just wondering, where do you find your infographics? I remember one of the earlier ones that I had attended, you'd used one on plastic bottles and plastic bags. And where do you find your infographics, and how do you decide which one to use? Can you tell me a little bit about that?
Yeah, gosh, I don't really have a good answer, but I'll tell you how I found this one. I was trying to think of a task where we were making things that were proportionate to body parts. Like, what is a similar thing in our world to the size of our hand? So I started looking up what's the average size of a human hand, what's the average size of, different things. And then I was like, oh, I wonder what the average size of a brain was. And this popped up. So my answer is I really don't have a great one, but some keywords, if you're looking for infographic, is just, typing that term in, the infographic. And then when I find one, I usually look at whatever's suggested in Google image search for others. But I don't have a great one. I spent a while trying to find a nice infographic for today's. I knew we wanted to compare two things and keep it really open, but yeah, that's where I was with this one.
I have a question, Trish.
Yeah.
So I see that you manage time extraordinarily well in terms of the math routine and then the rich task and then the little discussion at the end. Now, would it pan out the same way when you're working with children also, this distribution of time, or is this for adults?
Yes, it's the same way that I distribute time with any audience that I work with. Now, when we're first starting out, so when I'm working with, it doesn't matter if it's a class of kindergarteners, it's a class of eighth graders, people don't usually know to begin the task and that they only have 20 minutes to work on it. And they don't always know that the teacher's going to value all of your thoughts and opinions. And there's a lot of different ways of doing it. So those kind of have to be taught. And when we start off the rich tasks with students, the conversations aren't always as robust in the beginning. But some of the things that I try to showcase in the beginning is, if you just did the cross multiply, divide, like the standard algorithm, I'll probably value that, but not nearly as much as all the others, because I want to get, in their minds, what she's looking for is a variety of representations so that we can connect it during the discussion. So when we're first starting out, instead of 20 minutes for the work time, 15 minutes for the discussion, it might be a little bit more like 30 minutes for the work times, 5 minutes for the discussion, and then 10 minutes for the discussion, 12 minutes, and then working up to that 15. And in Smith and Stein's research for the 5 practices, they found that kids start off with this kind of show and tell mentality, like, this is what I did, and now we're going to see what this group did. And the tough thing is to connect those. And the more a group works together, that community is built, the stronger that connection will be. But I see it kind of more as a spectrum where you are with your group, with your task, with the rigor. But mostly I take what I get and try to listen out for those good questions and the ones that I've anticipated.
Thank you.
Well, folks, I hope you have a great weekend. If anyone has any other questions, feel free to stay on. Otherwise, happy Days.
Thanks, Teresa.
Thanks, Teresa. I have one more.
Yeah, sure.
Yeah, so I was just thinking now about what you said, that you might introduce this infographic and activity at the beginning of a unit, perhaps. And if that's the case, how do you see would it be 6th grade, perhaps, students approaching this? Because they don't know ratios or proportions so well yet.
So the idea of ratio thinking and proportional reasoning is something that kids develop like really early on. The idea of I've got a container of chocolate milk in 2 different size cups, that I don't want it to be halfway of each cup. Like, we're kind of greedy as humans in general, so we're learning this at a very, very early age. What's different about what they're doing now is the structure of how they're setting up their proportions, whether they're doing a really long table, whether they're thinking to double something, whether they are recognizing the factor-product relationship between them. And so the way that they go from unfriendly numbers, from friendly numbers to unfriendly numbers, is different by grade level. And so the sophistication of like how you structure it, like I want to put this number here, this number here, this is how we set up our proportions, this is how we set up a table, that gets a lot more detailed in middle school. But their initial questions, their initial reasonings would probably come out a lot earlier.
And would you, like I'm saying here, we're all adults, and somebody came up with a table and somebody came up with something else, and so there was a variety of sort of representations of the thought process. So for the children, would you suggest something? Would you say that you could use A or B or C, or that's not necessary in your experience?
So one thing that I find really important is that when we show different ways of doing something, so I might use a table, you might just use straight multiplication, and someone else might do some variation of doubling and halving. It's that not necessarily that I pick my favorite way and always do it that way, but instead I recognize that I have a favorite that I usually kind of lean towards. And now that I know that part about me, I'm going to offer that to the group, but also listen in more for things that I know might not be my favorite, because I have to be fluent in the language to talk with others. So yours might be using a table. I'm often very visual, and I think in visual ways. So by knowing my own bias, I can increase my confidence, but also know what to listen out for. So that's kind of how I chat with kids about their group dynamics.
Right. Thank you. Okay, I think I will say goodnight and thank you very much. Bye.
Bye-bye.
Bye, everybody.
Teresa, I do have one other thing.
Go for it.
When I was researching for another thing I'm doing, your site has come up, and that's how I recognized your site, or I came to know about your site. I was actually studying a book called Building Thinking Classrooms. I don't know if you are familiar with that.
Yes, Peter's book, yep.
Yes, and so I'm going to be implementing a lot of the ideas presented in his textbook, and I've already been in communication with him as well in trying to set up a professional development with our school system here in North Carolina. Looking forward to having that if we can make that happen. But I liked a lot of the ideas that he presented, and I could see a lot of the things that you were doing followed exactly what he was doing with the information presented in his book. And I like that a lot. So I'm definitely going to be coming back and listening in and participating with a lot of the workshops, because I want to get better at that myself so that I can relay that to my classes.
Absolutely. And, he talks a lot about non-permanent vertical spaces, and that is interactive slides if I've ever seen it. And the beauty of it is We don't have to spend a ton of money on getting a ton of different whiteboards or, pieces of stuff. And he calls them non-permanent. But the neat thing about Google Slides is that, if I'm going to use the table tomorrow, I might just copy group one's table and pop it in my slide so they can reference it.
Exactly.
So it's a little bit of a twist to that. I've used these slides both in person where groups or every student has a computer and that they're able to add it on. I've done it concurrently where we have some students in the classroom that have a computer and some that are at home on a computer, and they're interacting the same way. And obviously completely online. So that idea that we have a shared space also is really important to me, because too often I've been at a whiteboard and I haven't been the person who holds the marker, and I want my ideas on there too.
Right. I think this would serve as a great alternative way. In other words, if we had a snow day, for example, since we're not going to be able to just play in the snow now, this would be a great alternative way to come together in a shared space using Google Slides to do the same thing that we would be doing in the classroom. But I also could see having it split up where some of my groups would be doing the whiteboard and some of them would actually be doing Google Slides as well. So I see a lot of great ideas presented here and things that I could possibly try. And so I'm looking forward to it.
Absolutely. It's, it's my normal for the last, 11 years. It's where I'm in my comfort zone is, quite frankly, when I get up in a classroom and I'm there face to face, I find that my body's a little more exhausted. But we all know where we're comfortable at, and, there's my bias. That's what I'm comfortable in. But if you have other questions, come join us. We do this every Saturday. We tinker with some math. If you want to see other examples, I've got on my website over 50 other MATHurdays, and the structure is exactly the same. Here's a routine. Here's a rich task. And so there's a bunch of options on there. I was first and foremost a 7th grade math teacher, so I feel like everything comes back to 7th grade. It's like where you learn it all, but I bring it down to kindergarten and up to calc. So anywhere in that range is where we're seeing these.
Well, I found your information on your site too late last week to join, but I went in and I watched the video clip. And one of the things I liked, and I said, I'm definitely going to take this idea and implement it with my classroom, is you had spots for the students to put their answers in.
Yes.
Like you had like a little spot already set up on the slide, and you had enough for, I think you had like 30, 32, something like that on there. I said, that would be awesome. And then they could just put their answers in there, and then you just pulled that information, and for the ones that you wanted to have them discuss more about, I said, this is an awesome idea. So I'm actually taking what you're sharing, and I'm actually going to be providing some of this information with our PLT team and giving them some pointers on this. And maybe I can even persuade them to join some of the sessions too, to learn some things that you're doing, because I think what you're doing is great. So don't stop doing that by any means.
Thank you. I appreciate it. And yeah, what you're referencing there, this idea is what I call own a space. So I get it from the kindergarten classrooms. You see, as kindergartners, they can't just, well, they probably can, but there's a lot of structure involved in getting them to walk into a classroom and know where to sit. You think 7th graders are rough, like trying to teach that to kindergartners is interesting. And a lot of times teachers have a big rug on their floor, and there's these little colored spots, and they just know right away it's rug time, and 15 seconds later, they're all sitting where they need to be. And as a middle school teacher, I'm like, how did you do that? And so the idea is that when kids know their spot, they don't have any of this like thinking about where should I put this? Should I put this here? Am I going to feel like I need confidence in this? If they know their spot, they're more likely to put it there. So they're going to own their space.
There you go. I like it.
I have a couple videos that showcase that idea of own a space in a lot of different formats. If you're interested in seeing that.
That would definitely be helpful. Now, and I thank you for the link for the MATHurdays. That's actually where I went to see last week's. So that would be awesome.
Yeah, so let's see, I'm gonna give you the link for this.
I'm sitting on a green stage.
Why am I getting an ad? These are supposed to be ad free. All right, so here's the link. This one is for the Own a Space, and it really talks about how to use simple things like text boxes, where you put them, why you put them there, when you let students just add whatever they want, when you have it more structured and more. And so in that 1 hour video, I think I go through about 12 different ways that you can get students to participate on the slides. And so definitely check that out. And yeah, feel free to come again, write me, and let me know your feedback.
Oh, 1 second. I went to that, I clicked on it, and it took me directly into the video. Okay, I'm back.
Yeah, so that's got a bunch of different ideas. I'll give you one more link. I have a bunch of kind of PDs, shells of PDs that have been really good when people were first moving online. But yeah, check them out and keep in touch and give me your feedback, and love to see the way you connect us with Thinking Classrooms.
All right. Thank you so much.
Sure thing.
I enjoyed every minute. Thank you.
Sure thing.
Have a great rest of your day.
You too. Bye-bye.